The volumes, again, we're going to find the volume of this. So the idea here is that if you find the volume of a cylinder that fits around the cone, oops. Oh, it's because it's not going to let it be a not circle because of the circles unit. That's very clever of it. If you can find the volume of that cylinder, the cone is going to be a third of that. So we do pi times radius squared times height, which is pi times the radius is 3 squared times the height, which is 4, which is pi times 9 times 4. 9 times 4 is 36. 36 pi centimeters cubed. But that's the volume of the cylinder. So we need to take a third of it. 36 pi centimeters cubed divided by 3. And is that 12? I think it is. It sure is. That means that the volume is equal to 12 pi centimeters cubed, which is approximately 37.699 centimeters cubed. Probably pretty close to 37.7 for most people's purposes, but did I? Oh, look at that. I got it in a straight line this time, except that 3 is in the way. Get out of this way. Get out of the way. There. Okay. A right cone with a radius has a radius of 5 feet and a slant height of 13 feet. I'm going to draw this. So the radius is 5 feet. And we don't know the height, but we know that the slant height is 13 feet. So again, we've got to consider this right triangle here, where it's 5 feet this way for this leg. This leg, who knows? What a terrible leg. Gross. Hang on, I've got to put a stop to that. Let's do that better, shall we? Look, there you go. Isn't that nicer? I certainly think so. This is 13 feet. That is 5 squared plus an unknown number squared equals 13 squared. 5 squared is 25 plus unknown height squared equals 169. Subtract 25 from both sides. Question mark squared equals 144. Square root of both sides, get the question mark is positive or negative 12. Since it's a distance, it's positive 12. So the height is 12 feet, and I can continue. Because the volume of a cone is 1/3 times pi times the radius squared times the height. So the volume is 1/3 times pi times the radius squared, which is 5 squared, times the height, which is 12. Now, if you do 5 squared times 12, that's 300, which means the volume is 1/3 times pi times 300. And 1/3 of 300, you can do 300 divided by 3, or 1/3 times 300 is 100, which means that the volume of this cone is exactly 100 pi feet cubed, which is approximately, if you multiply it by pi, 314.159 feet cubed. That's how I would put it. Sweet. Again, sometimes you got to solve for the unknown bits. Finding the volume of a similar solid. So cone A and cone B are similar. The radius of cone A is 4 centimeters, and the radius of cone B is 10 centimeters. The volume of cone A is 134 centimeters cubed. Find the volume of cone B. Let's draw a picture. So here's your cone A. Or maybe if you prefer, there's your cone A. Huh? Cone A. All right, so let's see here. The radius of a cone is 4 centimeters. Cone A is 4 centimeters. 4 centimeters. And the volume of cone A is 134 centimeters cubed. Cone B has a bigger radius, so it's a bigger cone. 10 centimeters, and the volume is equal to who knows. So the point is that the scale factor of lengths will give you how many times bigger cone B is than cone A is, eh? All right, that's enough. Cone A. All right, I'll go ahead and stop trying to do my Minnesota accent. And then we're going to go ahead and do 10 over 4, because that's how many times longer the radius of cone B is than cone A, and I get 2.5. That's how many times longer 10 is than 4. That's what I did there. Now, K cubed is how many times more volume cone B has, so that's 2.5 to the third power, or 2.5 times 2.5 times 2.5, and I get 15.625. 15.625 is how many times more volume cone B has than cone A. So cone B should have 134 centimeters cubed times the scale factor for volume, 15.625, which I get 218.75. So the volume is 218.75 centimeters cubed. There's the volume of the big cone. Thank you, similarity. Finding the volume of a composite solid. So in this case, we need to find the volume of the cylinder and then the volume of the cone. So let's go ahead and get to that. So the volume of the cylinder is pi times radius squared times height, which is pi times the radius is 2 squared times the height, which is 5. 2 squared is 4, which means that's 20 pi inches cubed. Now the volume of the cone is equal to the pi times the radius squared times the height, and then we're going to divide that by 3 because it's a third of that cylinder that sits on top, which in this case is pi times 2 squared times the height is 4 over 3. 2 squared is 4, so pi times 4 over 3, which is 16 pi over 3 inches cubed. And that's not actually a very friendly number, 16 divided by 3, so I'm going to leave it like that. So the volume of this figure is 20 pi plus 16 pi thirds inches cubed, which if you really want to give that a common denominator, which I guess I do, see, I can change that into 60 over 3 pi, which means 60 plus 16 is a 76, so that's 76 thirds pi inches cubed, which again makes me feel gross. So I'm just going to go 76 divided by 3, which is 25.3 repeating. Multiply that by pi, and I get about 79.587 inches cubed. And I think that's it. Yep. There you go, folks. The volume and surface area of cones. I hope you learned a bunch. If you have any more questions, please send a message to your instructor. This is Mr. P signing off, and I hope you have a wonderful rest of your day.